Well, another Monday is here, and the way I'm doing this, I try to kind of put all of the images over on the side so I can have my face on one side, but so that the camera will mostly be focused on the pictures and the illustrations and stuff behind me. I'll need to turn around and reference them every now and then. But the point is, today I'm going to give you a flying trip through some electric power steering. Some of you guys are probably already really familiar with it anyway, but this is a fun little ride that I basically retooled a video that I had done for my students at the college. And I added more information and stuff like that. So even if you've seen the other one, there will be stuff this time that you hadn't seen before. We're not going to cover the electric power steering, in other words, the electric motor driven power steering pump. You know, some of the hydraulic power steering pumps are driven by electric motors instead of belts now. And I'm not going to be talking about that in this particular episode because those are kind of boring anyway. This one, electric power steering, has got some benefits to it. Basically, it doesn't use as much. It only uses power when it's having to steer the wheels. Now, your hydraulic power steering, whenever you've got the motor, even on the one that's driven by electric motor, it's always spinning all the time, and it's always pulling a little bit of power, even when the steering is not being used. Of course, it pulls more when it's being used. But on the electric power steering, as long as you're driving along and it's not having to do anything, if you're pretty much going straight, you typically don't have any kind of problem with electric power steering pulling any current. Of course, now I will tell you this, it will pull some pretty serious current. On my wife's pickup, she's got a 2016 F-150. I put my scan tool on it and I turned it against the locks a couple of times, and you know, it pulls some pretty heavy amps. You know, getting kind of up in the general neighborhood of about nearly 100 amps. You know, about 80, 90 amps if I remember right. Now, I've slept since then, but it was pretty high amperage whenever you turn it to the locks. All right, and so this basically, if you look, you'll see your motor right here is driving that worm gear, and that's what gives you your, and that's on the ones that's on the steering column. It's also the ones like on the dual pinion power steering is like that too, because you know, some of them have got, and I'll talk about that in a minute, some of them got dual pinion, some of them use ball nut. A lot of them have got this set up here, right up here under the dash, you know, on the steering column. And you can actually buy kits, like if you're doing a restoration on an old Oldsmobile or a Mustang or something like that, there are electric power steering kits you can get to put on those. Now they cost about $1,000, but it'd be pretty handy to have, you know, if you had the deal going on there. It's just also electric power steering can be utilized by some of your other systems, you know, for controlling the steering while you're going down the road, like some of this driver assist stuff. And it also, if you've got one that's doing it's parking maneuvers on its own, you know, it can actually handle the steering that way too. This right here was a kit, a conversion kit for a '67 Mustang. I tried to put a picture of on there, but it can operate it independently from the driver input, and it lets it perform all these other little things that you know, fancy stuff we're doing now. The primary purpose of electric power steering is to provide motor control. In other words, the control of the motor that drives the steering is what I'm talking about. The controller processor output drives 3 pairs of transistors that control the rotation of the motor. Now typically, this motor will be a DC, it's a brushless motor, and it's a 3-phase motor. And the way that the motor works on these, it basically has got the magnet part is on the inside, and the windings are on the outside, the you know, stationary windings. So you know, usually on your old your permanent magnet starters and power window motors and stuff like that, there'll be magnets around the outside, and then your winding will be on the inside where the brush is. Well, you cannot have a 3-phase brushless motor without some electronics. You're gonna, even the little fans in your computers, you know, the little computer fans like in a computer I'm using behind me here, if you take one of those fans, if you've got one of those little fans and you break it apart, down inside the hub of that thing, you're going to find some electric circuits in there. Those are brushless motors, but you're not going to be able to just have a brushless motor that you'll be able to hook 2 wires up to and it's going to spin. That's just not the way brushless motors work. Some vehicles now are using brushless motors for fuel pumps, and that kind of thing. And so you kind of need to understand a little bit about that. Well, this kind right here, the control module's built in. The motor is here. The belt and the ball nut style is what this is, and that's where your belt and your ball nut is. And you got a steering torque sensor right in here. That just gives you sort of an overview of what a lot of them are laid out like. They're not all exactly like that, but I really like the ones that I've been studying that have everything right there in the rack. And it's really handy. Your Dodge trucks have got a rack like this one, but they've actually got a module up there under the steering wheel where the clock spring is that actually is interfacing through the CAN bus with this thing. But on these right here, pretty much the torque sensor, the module, the motor, on most of the vehicles that are made this way, they're all built together. Whether it's belt and ball nut or whether it's dual pinion, they're all built in that one rack right there. All right, now an electric power steering system is going to maintain assist if the engine stalls. I'd say that, but whenever I tested that, I mean, it may be true on some of these with electric power steering, but when I tested that on my wife's truck, I found out that was a lie. Because whenever I switched the key on her truck, if the engine's not running, the power steering doesn't work, or at least it didn't feel to me like it was working. You know, you'd have the idea if it's electric power steering, you ought to be able to switch a key on and just turn the wheel with one finger. That ain't the way her truck works. Now, some vehicles might work that way, and I haven't driven and tested every vehicle that's got electric power steering on it. And a lot of the information you try to find on these is kind of foggy and vague, and you know, just sort of generic for this, that, and the other. Here's your belt and ball nut style. See that tooth pulley and that one there? Well, there's a ball nut in there that can run this rack back and forth as that pulley spins. Now, here I'm going to mention it one more time about these brushless three-phase DC motors. The belt is missing from this picture, by the way. But what you got, let me talk about this ball nut thing. If anybody that has ever disassembled an old parallelogram steering box, you know, the one you used to have to adjust on your old pickups and Crown Victorias and stuff like that before they went rack and pinion, inside there is a ball nut. And whenever you turn your steering column, that ball nut is basically what causes the steering to work down in there. I used to have my students when I was teaching, when I first started teaching over at the college back in the early 2000s, a lot of vehicles still had the old kind of steering gear on them. And I would have them to take those steering gears apart and get all those balls and that ball nut and all that stuff, and they didn't have balls all over the table on the rag and all that. And I'd make them put all that stuff back together so that it would work like it was supposed to. But that ball nuts are old. They've been around for a long time. Well, see, the cool thing about a ball nut is it doesn't provide this crazy resistance and stuff like you would have if you just had raw threads in there doing this. Eventually you'd have some galling and some wear, and you don't need to have that kind of nonsense going on when you're working with steering, because you need it to be consistently smooth. And that's what a ball nut will do. These balls ride in these grooves, and then they circulate back around, and it's just really a cool way to do that, I think. But there's the belt right there you're going to see on that rack, and it spins that ball nut and it runs the rack back and forth. All right, I'm going to tell you a little bit more about these motors here in a minute, but right now let's talk about this dual pinion system. The dual pinion system has got another pinion that helps the steering column, and that's what that's about. And there's a motor driving that. So you got an electric motor right here, and then you got another pinion over here, and then you got your steering torque sensor that's built right in here. You can see that it's going to go to the module, which is built into that. All of that's built together, which is really a good idea, it seems to me like. All right, let me see if I can get this thing to go again. Other inputs would be motor position. In other words, the module needs to know where the motor is. Some of you might have been involved with doing the electronic setup on these automatic up and down windows, and you know that in the first time I ever ran into that was in these Explorers, Sport Tracks. They had the back glass that would roll up and down. You know, they had a power window motor. You couldn't just swap out the power window motor in there. You basically had to put it in there and then initialize it. Then it would go up and it would go down 20 millimeters, and it had to find out where both ends were. And that's the way that even your air conditioner actuators under the dash that move the doors, they have to know where both ends are and where the middle is. And this motor needs to know that same thing. The motor position is really an important piece of data point. Motor voltage. How much voltage is it taking to drive the motor? It needs to know that. Motor temperature. How hot is the motor? If the motor gets too hot, You know, and it's going to stop it short of burning the motor out, basically. The module controller has also got adaptive memory and now diagnostics. In other words, how many of you have been driving down the road because you had a customer come in and they say, my car's pulling, and you find out it's a bad tire or there's something wrong with the alignment, that kind of thing. Well, this power steering is going to determine if you're having to fight this thing to keep it in the road because it's pulling over a period of time. It's kind of like fuel trim. It's going to work that steering so that it's fighting the pull for you. So when the customer's driving down the road, they may not even know they have a steering pull, but that module knows it, and it's going to have a PID that you can use to determine how much it's having. It's kind of like looking at your long and short fuel trims. I always tell people, whenever you go in looking for some kind of a running problem that's fuel trim related, you look at the long fuel trim first, because the short fuel trim is going to be at 0. The long fuel trim will be way off to one side, so it can keep the short fuel trim at 0. Well, the steering trim is like that on most of these electric power steering systems that I've studied. All right. The control unit takes inputs and drives the motor. There's your control unit. CAN bus is going to bring inputs in there from other places. You got your program in here, your steering wheel position, and your torque turning. Now, I'm going to talk a little bit more in a minute about the steering wheel position sensor. That thing predates electric power steering. On a lot of vehicles, the primary purpose of the steering speed and position sensor is vehicle dynamics. It has to do with that more than it does electric power steering, although, and sometimes the electric power steering will have the torque sensor and the steering wheel position sensor will be all built in there together. And that's typically the way that works on the ones that I've been studying. Other inputs come from the CAN bus on most models. There's your motor voltage input. See, this is an input back to the module, and so is that. And then here's your transistors that are driving those 3 windings in there. It's basically, some of these things have got a resolver in them. Some of them have got little Hall effect switches so that it can basically drive the motor the way that it wants to go. This is what it looks like inside, or actually what a map of the circuits inside a generic module right here. This blue part would be your control unit. You got a power supply, you got a microprocessor, signal conditioning that comes in. You know, if you've got some kind of analog signal that needs to change it to a digital signal so it can use it. Computers don't like analog signals typically. Current motor circuit is basically measuring across that little shunt right there. And your driver circuit that operates these, some of them use field effect transistors, and there's just various different ways that they do it. And there's your motor that spins the steering, and down here you got a steering torque sensor, which is right here, and then your steering angle sensor, which would be up there on the top. All right, now these motors right here, why use a 3-phase DC electric motor? The primary reason they use a 3-phase DC electric motor is because you want this thing to be just as strong when it's turning slow as it is when it's turning fast. A stepper motor won't work for this, and a brushed motor won't work for this. Well, a motor with brushes doesn't have near the power whenever it's turning slow that it does when it is turning fast. In other words, you don't want what you're wanting is you're wanting a motor that can turn slow and still have a lot of torque while it's turning slow. And from what I've been able to tell, that's one of the reasons that they use these 3-phase motors. Instead of brushed motors, instead of stepper motors, they want this thing to have some torque even when it's only moving the steering just a little bit. If you look at your power window motors, they kick into high gear as soon as you turn them on. Well, this one right here, you can't always have this thing jerking the steering wheel back and forth. These people that came up with all this thought it out really well, because if you didn't build it right, whenever you went to turn your wheel, it would take the wheel away from you and jerk it too far if they don't have a motor that will work the right way. And that's one of the reasons they use the DC brushless 3-phase motors. All right, and there's the pinion gear and the motor. Remember, the magnetic part of it that spins is on the inside, and the windings around the outside are what creates the magnetism that drives that magnetic spinning part, which is pretty handy. All right, when the steering wheel is turned to its maximum rotation, the module will command the maximum amount of current to the EPS motor, but if you hold it there too long, it's going to protect the circuits. And it can, if you get it too hot, you can basically it'll reduce your power assist to protect itself. Of course, it always seems to me like it needs to protect you too, But at the same time, I don't know if you've run into this before, but on some of the mid-2000s Chevy Cobalts and Pontiac G6s and stuff, they had steering modules that would had a tendency to fail. There was a recall on those, where they had to have the dealership replace them if it was before a certain mileage. The steering sensor has basically got a little wiper in there and all that. That's somewhat boring. You got 5 volts here, your output voltage there, that wiper going around. And so it's got 4 voltage divider circuits and a wiper. I don't even know why you need to know all that stuff. I just put it in there. And it doesn't always look like that. That sensor, like on the, we had to replace one because it had a stable track code on a Chevy pickup one time, and it's at the bottom. On that one, it was at the bottom of the steering column. We had to pull the steering column out of the truck, put it in the vise, replace that thing, put it all back together, and it was, quite a job on that one. But sometimes they're up on the top, sometimes they're on the bottom, sometimes they're built in the clock spring assembly. They're just all over the place. You're going to have to get your shop manual out and make sure that you're looking at the right one on all that. So this about here is just a funny little map I put of what the rotation input looks like. See how those things light up? They're turning it back, turn it to the right, turn it again. See, it just gives you a little bit of an idea how that works. This is one of the, these things cost about $500 or $600, and we've actually had to replace those on these vehicles here. One of the things that I've noticed about these is that there's all kinds of steering wheel centering and stuff steering sensor centering and whatnot you're supposed to do on there. One of the first ones that we did that had this is actually up inside the car on the steering column part of it on the Cobalt and the G6. But what we did on this one here, if I remember right, I'm doggone it, it's been so long. But anyway, we put one of those on here, and because it would just suddenly lose steering, and then it would get steering back, and then it would lose steering, get steering back, and this thing right here was crappy, and we put it on there and fixed it. If I'm not mistaken, and I could be wrong, and I could be giving you bad information, but I think this was plug and play. And when we actually got a used electric power steering rack for a Ford Fusion, it was like a 2010 model. We treated that one like a plug and play. We just put it on a car and plugged it in, sent it on its way. Now there was probably some kind of procedure we should have done that we didn't do, but at the same time, the students were doing it. And when this guy was just so desperate to get this car where he could drive it, when this power steering goes out, you ain't driving it nowhere. That's the worst part about that. If I'd had good sense, we would have took his old rack and pulled it apart, and I could have used it for an instructional thing, but we were swamped with so much live work, I didn't even think about doing that. Just sort of bobble the ball on that deal. All right, your torque sensor, and they look various different ways. That's just a representation of it. The torque sensor performs the same function as the spool valve in a hydraulic system. On a hydraulic system, how when you turn the wheel, a spool valve moves and it directs the fluid this way and then that way. It's that way on tractors and all kinds of stuff. Spool valves are really an important part of the steering on a lot of vehicles here, like on your rack and pinion particularly. It directs the fluid first to one side then the other. There's different types of electronic torque sensors. They're classified as contact and non-contact sensors. This right here is a torsion bar. It's put in there, and basically what you're doing is that sensor measures how much that bar twists when you're turning the wheel, and that way it knows how much assist to give you, or how suddenly you want to turn the wheel, how fast you want to turn it, how far you want to turn it, and all that. And that's not all that complicated, although it's not easy to build that so it'll work right. Isn't it kind of scary to have that skinny little thing that's twisting every time? Seems like if you bent a piece of wire back and forth, it seems like it would twist and twist and twist until finally it just broke one day, But I'm sure it's special kind of metal. The contact type sensor uses a wiper attached to the torsion bar. You can freeze that slide and read those words if you want to. And steering angle sensor. All of this stuff is factored in, and the algorithms in the computer will take care of that. In your Toyota, whenever you're putting one on a Toyota, you're supposed to have it'll throw you a code if the steering assist map hadn't been written. And there's only like 3 steering assist maps, and I think it has to do with what part of the world or what part of the country you're in, depending on whether you're used to driving on the left side of the road where the crown's in the middle, and that kind of thing. It's just, that's if you go rooting around looking for a steering assist map information exactly what that is, Toyota's the only people that talk about a steering assist map. But I'm sure the same thing is used by, is addressed by different terms using the other automakers. All right, and that's the network communication there. You got all of that stuff is going to be fed in there through the network. This is sort of the inside of the controller again, and it's giving you some more of that hogwash. You can play around with that if you want to. There's your CAN bus going out that way. And of course, you got differential speed, torque, steering angle. Speed of the vehicle is important too. Why is the speed of the vehicle important to the steering? Because when you're driving down the road, it will typically give you less steering assist when you're driving than it will when you're in a parking lot maneuver. Because if you've ever had a lot of steering assist, it's real easy when you're driving down the road. It makes the car feel squirrely. So you want the car to feel like it's got a little bit of, resistance to the steering whenever you're driving down the highway at a, rate of speed there. And there's your CAN LIN receiver, that so on and so forth. So it actually, on the Dodges, unless I miss my guess, the CAN and the LIN come together in that module that's under the steering wheel, which is kind of like your clock spring and all, and that's giving it your steering angle and that kind of thing. And that's on Dodge. If the module detects high temperature and overload protection, it'll give you a CO176. On the GMs, on some of them, CO476. Electric steering motor circuit range performance may be set, and they indicate normal action, reduced steering assist to prevent thermal damage to power steering system components. Always find and read your description and operation page. You need to know really well how the one you're working on. For years and years and years, if we had something that was fuel injection or whatever, we would just rely on what we remembered about the cars we had fixed before. Well, these cars right here have got a lot of different rules. It's kind of like working on gasoline direct injection. You're basically going to have to find out with every different make and model, and sometime from one year to the next, what the changes are, what you need to know about the one you're working on, so you won't get in trouble. Of course, some of the same rules apply, like harness routing, connector pin fit, corrosion, this kind of thing. There's all kind of stuff that's just standard procedure when you're working on anything electrical that also applies to this. And after any alignment, you're supposed to do your steering angle sensor centering or anything like that. And remember, it's always a good idea too, if you're working on one that's had a steering pull, that it's had to use the steering pull compensation. You need to clear that like you would your you won't know if you've got it fixed or not if that steering pull that pull compensation learning has dialed itself in, and here you are driving down the road trying to test drive one, and it may try to pull the other way because it has, you need to wipe that memory out. Disconnect your battery cable, clean all that stuff out of there so that you can, or go in your scan tool and wipe it out that way so that you won't be, you'll know. It's kind of like when you're doing a fuel system repair. You always want to clear your memory so you can fire it up and see what this thing is doing and see if it goes crawling really far and fast again. That way you didn't fix it. On this one here, if you clear all that, you want to be able to drive it without it, to see if it's pulling and to see if the module starts to apply effort to keep you from feeling that pull. Use the scan tool and look at, there's a PID right here on my wife's truck. They've got long-term pull compensation, final pull compensation. This is in a foot-pound PID. You'll be, how many foot-pounds it's having to apply. It'll be close to zero, kind of like your fuel trim should be, Anyway, this was a flying trip. I hope you got something out of it. Hope it wasn't a waste of your time. I really enjoy gathering all this information because it kind of helps me stay on my feet about this stuff too. And I really appreciate you guys watching, and I will be seeing you next time.